Hello everyone. I recently created an introduction to memory forensics video, and in that video I promised a follow-up video that explained some basic Windows forensic analysis techniques and showed some basic Windows artifacts that we commonly look for. So this is that video. On your screen you'll actually see a DFIR cheat sheet that I created. DFIR, by the way, is Digital Forensics and Incident Response, if you're not familiar with the term. This cheat sheet actually has a very small subset of the information covered in the SANS FOR 500, formerly FOR 408, Windows Forensic Analysis class. That class will actually prepare you to sit for the GX Certified Forensic Examiner, GCFE certification. I know a lot of people will skip it and go directly to FOR 508, which prepares you to take the GX Certified Forensic Analyst, GCFA certification test, but honestly, you are doing yourself a disservice if you don't already know this information. In fact, when you take 508, it is assumed that you are familiar with a good bit of this information already. And certainly to win the final challenge in that class and really to succeed as a forensic investigator, if you're forensicating Windows boxes, you need to know this material. So again, this cheat sheet has a very small subset of the forensic artifacts that are available to us on a Windows box. In case you didn't realize it, your operating system is spying on you. There are a ton of things in Windows that provide a wealth of forensic information to investigators. But the interesting thing to note is that these things were not put there by Microsoft for that purpose. They all serve some other purpose. For example, perhaps there are things that help programs launch more quickly, or things that ensure backwards compatibility when you're running a legacy piece of software on a newer operating system, or things that improve the user experience. Whatever the case may be, Microsoft has not provided this information for forensic investigators. The other thing to realize is that these things can change. They often change. In fact, when service packs come out, or now I guess it's more of a rolling release model with Windows 10 Redstone 1 and Redstone 2 and so on and so forth, there is no guarantee that a forensic artifact is going to remain across operating system releases. Now, luckily, most of the things on this particular cheat sheet still remain, and they are usually found in anything from Windows Vista and above. So what I'm going to do is actually go through and first off talk about the registry itself and how it's laid out on a Windows system. And then we're going to look at some demos in different sections of these particular artifacts. I'm not going to show every single one of them because the video would be hours long and take forever, and you might fall asleep or lose interest. So let's just hit the highlights of some of the most common ones. But before we do that, you'll notice that we've got HKCU and HKLM that are commonly referenced here. That's HKey current user and HKey local machine. So let's figure out what that means and what the registry is and where it's located and all that good stuff first. Basically, the Windows Registry is a giant database that comprises a huge amount of information that the operating system uses to function. It basically stores information about programs and settings for programs and just all kinds of information that is vital to make the operating system work. The registry itself on disk is actually found in Windows System 32 config. So if you're looking at a live system, first off, it's important to know that the operating system protects all of these files within this path, so you can't edit or open or copy or do anything with these on a live system unless you use FTK Imager or something to get out of them. But otherwise, the operating system is going to protect them. But if you look here, we've got default, SAM, security, software, and system. These are the most common registry hives, the most important registry hives that we grab when we forensicate a Windows system. In fact, automatic backups are taken and stored in regback, and you'll notice right here, default, SAM, security, software, system, the same ones I just mentioned. So when we grab information from a Windows system, we'll most certainly grab the registry hives out of config and also the ones out of regback. Regback will be important because let's say someone attempts to perform anti-forensics on us and delete things out of the registry, purge things out of the registry. Even if they do it correctly, if you delete something out of the registry normally, it's pretty easily recoverable, but if you compact the database or do other anti-forensic techniques to make that not possible, it's possible that you forgot to purge the backups in regback, so we'll often grab them as well. So default, SAM, security, software, system. And also, if we look at user profiles, every user profile has an NTUSER.DAT file. You don't see it in the GUI here because I'm not showing system files or hidden files, but if we drop to the command prompt and I run dir/ah, you'll actually notice here NTUSER.DAT. Now, NTUSER.DAT actually plugs into the registry as HKCU, HKey current user, when you're browsing a live registry on a live system. So every user has an NTUSER.DAT, which is kind of like that user's chunk of registry-related information. So certainly we'll want to grab NTUSER.DAT, if nothing else from the profiles we're interested in analyzing, but usually across the board we'll grab all the NTUSER.DAT files from all of the profiles. There's also another one called UsrClass, UsrClass.dat. We'll talk about that a little bit later, but that's also a registry hive that is user-specific that plugs into a specific registry location. If we run regedit on this live system, if we look over here, HKey current user is again NTUSER.dat. So for my particular user on this live system, HKey current user is actually being read from NTUSER.dat. So the terms are somewhat interchangeable, though usually when we speak of HKey current user, we're talking about analysis of a live system, and when we talk about NTUSER.dat, we're talking about parsing a file on a dead system. If we expand HKLM, you'll actually see those other hives I mentioned. For example, SAM security software and system, which plug in to those files that I just showed you on the file system. Now, hardware and some other registry paths that you see here are actually generated on system boot. They are not stored on disk. They are dynamically generated based upon the hardware in the system and the drivers loaded, etc. So you actually won't find, for example, a hardware hive on disk. So that kind of provides you with some very basic information about how the registry is laid out. If we go back over to the cheat sheet here, the first path that you'll see is current user software Microsoft Windows current version Explorer. Now, what I'm going to do is on this very system, I actually grabbed a copy of the registry hives, which are right here, the ones I just mentioned, including NTUSER.DAT. We'll actually use one of many pieces of software to analyze this offline. In this case, I'll use Registry Explorer. It's a free piece of software. As of this recording, version 0900 is the newest. There are plenty of other tools from Access Data and other companies that you can use to explore the registry. But this particular tool will be fine for our purposes. So let's go ahead and go to File and Load Offline Hive. And we'll look at, on the desktop, and we'll look at NTUSER.DAT. Now, first off, earlier I mentioned that when you delete something out of the registry, unless you perform additional anti-forensics, it is very likely that that data can be recovered. Those keys and values can be recovered. And in fact, if you look here, you'll actually see some deleted records. We're not going to worry about that for now, but we're just going to expand root. And we're going to go ahead and go down to Software and Microsoft and scroll on down to Windows and current version. And we will look for Explorer. So if you look down at the bottom, Software, Microsoft, Windows, Current Version Explorer, which is the root of where all those first pieces of artifact information are located. Now, let's take a look at each of these. ComDLG 32, or Common Dialog 32, is kind of interesting. Within it, last visited, I'll call it PIDL, PIDL, MRU, and Open Save PIDL MRU can be found. Have you ever noticed that when you launch, let's say, a word processor, and you open a file from a specific location or save a file to a specific location, and then maybe a few days later you go back to your word processor and go to File and Open, the last path that you were browsing is still there. Well, that information is actually stored in this particular registry key. Last visited PIDL MRU actually talks about or stores the binaries that have been used to open or save those files, and then Open Save PIDL MRU actually contains the files themselves, or actually the paths for the files themselves that were opened or saved there. So that information, if you've ever wondered where it is located within that registry key. That can provide some information, including information about files that may have been since deleted on the system, but maybe we see evidence that they were at one point browsed to or opened with a particular program. So ComDLG32, and underneath it, last visited PIDL MRU and Open Save PIDL MRU. By the way, MRU is most recently used. You'll see that throughout the Windows registry. We'll talk more about that in a second. Recent docs. If we go over here, and again, I'm not going to show you every single one of these because that would take forever, but recent docs is a pretty common one. If we look at that, there are actually various things that we can parse through here that will actually show recent things For example, here's some link files I've recently opened. Registry Explorer link file. And here is another link file. And here's a Nearsoft Tools link file. So these kind of things in recent docs can actually show recent things that have been interacted with on the system, recent things that have been opened or saved. So recent docs is a very common registry key that we'll look at. There are plenty of tools that will parse all of these things for you automatically, by the way. In fact, RegRipper, which is an awesome utility that's built into the Sans Sift workstation, and you can download it obviously and use it anywhere you want on any Linux box, but it will actually parse the registry hives for you and grab all of this information. But I think it's important that you know where it's located anyway and what it does. So let's look at another one called runMRU. So if I bring up the run prompt here and I type in something like notepad, that information is actually stored in the runMRU key. If we look right here, the first value you see here, or the first one we're going to look at anyway, is MRU list, most recently used list. And you can see this BAFEDC. That actually corresponds to this. This means that in the run blank, in this order, CMD was executed, then just slash, then it looks like PowerShell.exe, then MS Paint, then CMD.exe, and then Notepad. So someone actually went to the run blank and ran those particular things. And when we say someone, we obviously know which user did it because we have their NTUSER.DAT file. So we know that that particular user is the one associated with running these particular programs from the run command prompt, or the run dialog box, I should say. So this is a very interesting registry key to parse, obviously, for a number of different reasons. Now, typed paths is another interesting one. If we bring up the Windows Explorer here, and I type an explicit location, such as /program files /CCleaner, that particular path I explicitly typed into Windows Explorer. That would tend to indicate that I knew what I was looking for and I knew of the existence of the path. So another interesting thing is, if we look at this key, we'll actually see, and again, this came from this very system, even though we're looking at an offline hive. I actually grabbed this hive not very long ago, maybe 20 minutes ago, but we'll see a reference to /MSF. There is no /MSF. So that's interesting. There's actually evidence of a path that once existed that's now been deleted. MSF, I wonder what that could be. That could be Metasploit framework. It could be, well, a number of different things, but maybe that would be of interest to us. So we'll actually see that here. That means someone explicitly typed that path in the Windows Explorer, as did they with // and also // program files /Sublime Text 3. So that would tend to indicate that someone didn't just stumble upon it, they explicitly typed that path in Windows Explorer. And you can imagine in an investigation that kind of information would be most useful. Another thing, or the last thing actually in that first section, was UserAssist. Now, UserAssist is one of many different things on a Windows system that will actually show us evidence of application execution. So UserAssist will actually show us when a particular program was executed and how many times it was executed, and obviously we know which user executed it because UserAssist is associated with the HKCU or NTUSER.DAT file for a specific user. So the values within it, these GUIDs, actually correspond to various paths, and there's a well-known lookup table for all of this stuff. And within it you'll actually have counts, and there are a bunch of different things here that we can find. For example, this one has 186 objects, but if you look at it, it kind of looks like gibberish here. That's because these values are ROT13 encoded. Now, ROT13 is a simple substitution cipher. It basically takes an alphabet and shifts it 13 characters. So A becomes M, B becomes N, so on and so forth. I'm not exactly sure why Microsoft chose to do this. It certainly obfuscates it if you're just looking at the data. It's very, very easy to deobfuscate it by Googling ROT13 decoder or just writing one yourself, which takes only seconds. But there are also a number of different tools that will just parse this particular key for you automatically and pull out all the information in a nice GUI or at the command line. But this information is very useful because we can show, again, when a particular GUI program was launched on a system, how many times it was launched, and who launched it. So very, very important when we're forensicating a Windows system. Now, if we go back over to the cheat sheet, you'll also notice that very similar paths here under current version. You've got run and run once, both for current user and local machine. These are locations, one of 50 or more locations, in fact, on a Windows operating system where programs can be specified to start upon login. One of many places where this can happen. In fact, if you look at, for example, let's look at Task Manager here, and then let's click on the Startup tab. You'll actually see two things listed here, the VMware Tools Core Service and Windows Defender. So on this system, let's load up regedit actually. Let's look at it live. So if we look at regedit and we go to local machine, software, Microsoft, Windows, current version, run, we'll actually see those paths right there. There's VMware Tools and there's Windows Defender. So those are again locations of things that are starting automatically with Windows. The same path exists not only under HK local machine, as you can see down here, but the exact same path exists under current user, which means user specific things that are starting at startup. So in the next section of the video, we'll actually talk about something called ShellBags, which is one of the oddly named Windows forensic artifacts. We'll actually talk about what ShellBags are and what forensic evidence they can provide. By the way, if I didn't mention it already, this particular cheat sheet, again, I will link to in the description of the video. You can also find it on my website at 13cube.com. So if you want to grab it and print out a copy of it for reference, feel free to do that. Okay, next let's talk about ShellBags. What are ShellBags? Well, as you can see under HKCU, Software Microsoft Windows Shell, there exists some registry keys and values that are of interest to us, bag MRU and bags. Now, most of the time you are not going to parse ShellBags manually. You certainly could. In fact, you'll learn how to do that in the class I mentioned previously. But most of the time you'll use a piece of software like ShellBag Explorer or some other utility that will automatically parse that for you. So what is it? Basically, when you visit a particular path in Windows Explorer and you customize the icons and the look and the feel of the folder, the window position, the size, the icons, the sorting method, all of those things, those are stored in ShellBags. The reason why it's important from a forensic standpoint is because ShellBags persist for things that have been long since deleted on a system. So we might be able to find entire trees that are completely gone and haven't even existed on the system, showing that at one point said path did exist on the system. So there's all kinds of different forensic ways to parse that data, and certainly a lot of advantages for looking at it. So let's briefly look at, from the same people that brought us Registry Explorer, we've got ShellBags Explorer. So let's load up ShellBags Explorer, and let's take a look at the live system. If you recall earlier, there was a path in the root of C called C:\MSF, which no longer exists. If we go to File and then Load Active Registry, it actually gives us a parsing complete message, and it shows how long it took and what it found. But if we go down here, we'll notice a ton of stuff that it actually parsed from ShellBags. And if we go down to My Computer and then look at the C drive, we'll actually see an MSF directory. Now, it's got some modified information and date information and path information and things like this, but again, this path doesn't even exist on the file system anymore. So the fact that we can actually see that it once existed and have some date and time information associated with that is extremely important. You'll also see things like E, D, and S listed here. Now, those are either network paths or removable volumes that once were mounted on the system but aren't. We can go through those and parse those as well and see evidence that perhaps a flash drive was connected at some point and used to browse to a particular folder that contained some sort of, anti-forensics tool or some hacking tool that we're trying to investigate, or maybe some contraband someone was using on the system or copying on the system. We can find that information by parsing these ShellBags and looking to see that those paths once existed and when they existed and where they existed and under which user they were accessed. All of those kinds of things can be found by parsing ShellBags. Now, there are entire websites devoted to how to understand and utilize ShellBags in forensic investigations. I'm not even going to attempt to scratch the surface here. I just want you to understand, when you hear the term ShellBags, what is that and what is it used for? And now you know at least the basics. I would encourage you to read more on that. There's actually some SANS gold papers that have been done on that, so you might want to check that out. So again, ShellBags Explorer is a great tool, and there are plenty of other ones that can be used to actually browse those things. They also, by the way, exist in all versions of Windows, so they're whether you're analyzing Vista all the way up to Windows 10, you're still going to have ShellBags to parse. Now, in the next section, we're actually going to briefly mention something called UsrClass.dat. I think I mentioned it earlier. It's another section under which a user-specific piece of the registry will be stored. So we'll talk about exactly what that is, and I'll show you where it is. Okay, so now that you know what ShellBags are, at least at a high level, let's talk about UsrClass.dat. If we go over here, we'll actually see on the cheat sheet that user profile, app data, local, Microsoft Windows, UsrClass.dat is the path that we're talking about for this particular registry hive. This is something that we will certainly want to get when we grab data from a particular system of interest. So again, this is the path here, and it actually plugs in to the live registry at HKCU software classes. So UsrClass.dat is actually something that was added in Windows 7, and in fact this Windows 7 ShellBags article will actually mention it. But the basic purpose is segmentation from low integrity processes that do not have permission to read and write to the standard registry. They can do so within UsrClass.dat. If you scroll down on this particular SANS DFIR blog, which is from 5 July 2011, you can actually see that it mentions that you need to parse both NTUSER.DAT and UsrClass.dat, and it also mentions the fact that ShellBags information is actually present at this path in UsrClass.dat. So we had just talked about ShellBags, but also know that ShellBags are not only found in NTUSER.DAT or HKCU, but also in UsrClass.dat. And again, it even says here, in oversimplified terms, it is used to record configuration information from user processes that do not have access to write to the standard registry hives. So again, it was a security feature added to provide further segmentation within Windows 7 for registry hives. So again, grab UsrClass.dat. Another important thing to mention is oftentimes FTK Imager is used to grab forensic data from a system. A lot of times people will use the little safe icon here for obtain protected files. Please be aware that, to my knowledge, as far as this video is being recorded, that button, that icon, does not grab UsrClass.dat from each user profile. It does get into user.dat, but it doesn't grab UsrClass.dat. So make sure that when you're forensicating a system and grabbing that data that you do grab UsrClass.dat. And again, the path for that is app data local Microsoft Windows UsrClass.dat. So the next section, we're actually going to transition to talking about USB devices, which there are obviously tons of different reasons why we want to know which USB devices were plugged into a system at any given time, and what was accessed, and who mounted them, and etc. So we'll talk about that in the next section of the video. Okay, so now let's talk about USB devices. There are obviously a number of reasons why we would want to know what USB mass storage devices or flash drives have been plugged into a given system. And by analyzing the right registry paths, we can find that information. As you can see here, HKLM, System, Current Control Set, enum, USB Store, and USB can provide a wealth of information. Now, I would like to mention that Current Control Set is displayed here. You're only going to see Current Control Set on a live system. So on this live system, if I load up regedit, and I look at local machine and system, sure enough, here is Current Control Set. If I'm analyzing a forensic image that I've obtained previously, however, there will be no Current Control Set. Instead, I'm going to analyze Control Set 001. But what if there were Control Set 002, 003, and so on and so forth? How do I know which control set was actually last used on the system? There may be more than one if the system had had trouble starting up or Windows had automatically attempted to correct some sort of issue on startup. If we look at the select path here and look at the key called current, it has a value of 1, which would indicate that control set 001 is the control set that we would want to analyze. We could make that assumption in this case because there is only one control set, but in forensics we don't make assumptions. We look at the evidence and determine for sure by looking at the correct key. And in this case, again, control set 001 is what we need to be looking at. So let's get out of the live registry view here and let's actually load up the Registry Explorer like we used last time. Now I can tell you during the last break I took a Samsung USB flash drive that had not previously been connected to this virtual machine and I connected it to it. So I know what the serial number of that device is, so I can identify it here and we'll actually look at it and see if we can determine some information. So let's load offline Hive, let's browse to desktop and click on System. Now, according to the cheat sheet, we should look at, again, this is not a live system, so there's no current control set, but enum, USB store, and USB. So over here, we have got control set 001. Sure enough, there is no current control set. Enum, and let's look at USB store. There's one value here, which is correct, because there's only been one flash drive that I've recently plugged into this virtual machine. It is a Samsung flash drive, and if I further expand this string here is in fact the serial number for this device. Now, because the ampersand is near the end of the string, I know that this is likely a globally unique serial number, and I would record that information. If, however, I saw an ampersand in the second character of the string, that would indicate that the manufacturer of that flash drive did not follow Microsoft guidelines and did not assign a globally unique serial number to the device. So Windows would automatically generate a serial number that would be unique on that system, but not globally unique. In this case, this is a Samsung flash drive and it does have a globally unique serial number, and this is it. So I would certainly record this information ending in 22277. So now I know the make of the flash drive, that it's Samsung, and I know the serial number. If you look over here, I also know the last write timestamp of this particular key. 2017-6/3 at 04/27/34. Now these times, as are all times in Windows, are recorded UTC. Because it's UTC, I would need to convert it, and upon converting it, that would be 12:27 a.m., which was about 30 minutes ago, and that's correct. That's when I first plugged that drive in. So that's an interesting piece of evidence right there. I know the first time the drive was connected. If you look over here, I can also see some more easily readable information. Samsung flash drive Duo 1100, it says here. So now let's expand the USB key, and we'll see some vid and PID entries. The vid and the PID, by searching on Google, we can find various lookup tables for vids and PIDs, and we can actually find a more specific hardware make and model of the device by matching the vid and PID to a known database. If I look at the vids and PIDs listed here, this first vid and PID happened to correspond to the serial number we saw below, 22277. Therefore, I know that the vid is 090C and the PID is 1000. If I looked at that information, that would tell me more information about the make and model of this particular Samsung flash drive. So again, good stuff there. Now, the next key that's listed on the cheat sheet is under the software hive. Because I've opened the system hive here, we'll need to switch. So I'll go ahead and unload all hives, and I'll go to File and Load Offline Hive, and on this time I'll choose Software. Now, while that loads, the path I'm looking for is going to be Microsoft Windows Portable Devices. So under the Software Registry Hive, once it loads, we'll browse to that particular path. Now, while we're waiting on that, we will actually go back to the System Hive after we're done parsing that and look at a key called Mounted Devices, where we can find additional information. This is a particularly large registry hive, so it may take a little bit to load. Here it is. So now, again, we're under Microsoft, Windows Portable Devices. So there's Microsoft. Scroll all the way down here. Windows Portable Devices. Now it appears that I have 3 listed here. If I mouse over each, I'll actually see that the second one corresponds to the serial number of the device in question. It even says Samsung, and you'll see the 22277 for the serial number. Over here, we'll see friendly name, and then the data is sticky. Sticky is in fact the name of the volume for that flash drive that I plugged in. So now we know even more information. Again, if we look at the last write timestamp, we can actually see 4/27/35. So we again know in UTC time and date that particular flash drive was on the system. So now we'll switch back over to the system hive. So once again, let's unload all hives, and let's go to File, Load Offline Hive, System. We'll give that a second to churn. And this time we're going to be looking at a key called Mounted Devices. So, if we look at Mounted Devices, we'll actually see on the right side many different entries here. So what we'll need to do is match up the serial number in order to find the GUID. Now a GUID is a globally unique identifier. Some people call them GUIDs. I call it GUID, but whatever. It's a globally unique identifier for that particular item on the system. So let's scroll down through here, and it looks like USB store Samsung flash drive Duo 1100. And you'll see 22277 for the serial number. So this is the device. And now it appears that I can copy this particular value, and now I've got the actual volume GUID for the USB device. This is an important piece of information that I want to record, because the volume GUID would be globally unique on this system, and any other references to that volume GUID could show evidence that that flash drive was used for various things. Now we can also look at the serial number to obtain the drive letter of whatever drive letter was assigned to that device. And you can see right here that, sure enough, USB store Samsung flash drive Duo Rev 1100. Here's the serial number 22277. I therefore know that this was mounted as the E drive on the system. So now I know the make and the model, the vid and the PID, the serial number, the volume name, that it was mounted as E, and I even know the first and last time that it was mounted. So all of this information is extremely valuable, and again, I would record all of this information in an investigation for any USB external devices that would be of interest to me. Now, there are numerous tools, including some from a company or individual called Nearsoft, NIRSOFT. There's also USB device forensics and several other different utilities that you can use to parse all of this information automatically for you, but it is important to understand what those tools are doing and how to find that information manually yourself. Also, as a point, never rely on a single tool. Always have more than one way to get the data. And if you've got 2 different tools that are giving you 2 different outputs with conflicting data, then you've obviously got a problem. So again, it's important to know where this information is actually located so you can manually parse it should you need to. Now, the next key, which is Software Microsoft Windows NT Current Version EMDM-GMT, which stands for External Memory Device Management, is only going to be present if the device in question is not a solid-state drive. It was actually used for something called ReadyBoost back in Windows Vista, and you can actually find the serial number to obtain the volume serial number of a USB device. Now, the volume serial number will be actually displayed in decimal, but you can convert it to hex. What I mean by that is, if you load up a command prompt here and I type DIR, you'll notice right here volume serial number, which is in hex. This is the volume serial number to which we're referring. And the interesting thing about this key is, if again it's not an SSD, you can actually find an entire history of volume serial numbers for the USB devices. even if the device has been formatted multiple times, we'll actually have a history of the volume serial numbers. Now again, this is not the serial number of the device, but the volume serial number. So that's a bunch of interesting information that we can also obtain. We can show how many times the device was formatted and what it was previously assigned, what it was called, what the previous volume serial number was, so on and so forth. Now, the next thing we'll look at is the fact that the volume GUID that we found in system-mounted devices can actually help us find the user that mounted the USB device, which is another piece of interesting information. So by that, if we go to File, Unload All Hives, and go to File, Load Offline Hive, this time we'll load up NTUSER.DAT. Now, as we're loading up NTUSER.DAT, which again on a live system is HKey current user, we can go to the same key that we mentioned above, or the same path that we mentioned above, which is Microsoft Windows Current Version Explorer. There's actually another key under here of interest called Mount Points 2. I don't know what happened to Mount Points 1. I guess that's not important, but Mount Points 2 is what we're looking for. So again, the full path of that was Software Microsoft Windows Current Version. So let's go ahead and drill down. Software Microsoft Windows Current Version. Now we're going to go under the Explorer, which is where we started with this video. And if we look down here, sure enough, there's Mount Points 2. Now, according to the cheat sheet here, we can actually use the volume GUID to find the user that mounted the USB device. Well, the volume GUID ends in FB35B, it appears. So if we take this column and expand it a little bit, there's FB35B. So now we know, and by the way, there's the timestamp associated with it, last write timestamp. We know that the user last mounted this device at this particular date and UTC time. Now, obviously, we know what user it is because we're looking at this user's NTUSER.DAT file, which is my user. So now I know that my user mounted this very flash drive. In addition to all the other information, we can add that to the list. So again, you can see how that would be very, very powerful. Now, we can find also by parsing system current control set, or again, control set 001, or so on and so forth on a non-live system, enum, USB store, the vendor product version, USB serial number, and then underneath the serial number there's a key called properties. And this GUID will remain the same. It ends in B29. If I look at this GUID and look for the values 0064, 0066, and 0067, I can actually find the first time the device was plugged into the system, the last time the device was connected to the system if we're talking about Windows 8 and later, and with Windows 8 and later, I can even find the last time the device was unmounted and removed from the system. So again, underneath this long path here, there's a properties key ending in B29 for the GUID, and if I look at 0064, 66, or 67, I can find the first time the device was installed, the last time it was connected, and the last removal. Now, the last connected time could also be found by looking at the last write time of the enum USB vid PID key that we looked at earlier, or the Mount Points 2 GUID key that we just looked at. The first install time can actually be found in setupapi.log or setupapi.dev.log. Now, in Windows XP, it was called setupapi.log, located in the root of the Windows folder. And then in Vista and later, it actually lives in Windows INF setupapi.dev.log. But that actually contains plug-and-play hardware installation information, so it would actually show us the first time that the user actually plugged in that USB device, the first time the system saw that USB device. So again, additional information that will be very valuable in an investigation. Now, I mentioned earlier USB device forensics. This is an application written by Woneware, and it can automate all of these things. But as I said, you need to know what the tool is doing. Don't just blindly depend on a tool to parse the information for you. You need to understand what it's doing behind the scenes, and maybe you would even want to double check the tool. Tools aren't perfect, but if you get output from a tool that doesn't look quite right or is not what you're expecting, then go and manually visit these particular registry keys, and you can look and determine whether or not you believe that information is correct. Okay, so back to the Windows 10 VM. Let's go ahead and take a look at these last two forensic artifacts for USB devices. So I've got Registry Explorer opened, and I've opened the System Hive, and I've drilled down to control set 001, enum, USB store. I found the particular USB device in question, which is the Samsung device from earlier. You can see the serial number 22277 that we saw earlier. Underneath that, properties. And underneath that, you'll notice in bold is that particular GUID that I referred to earlier that ends in B29. So underneath that, you will actually find 0064, 0066, and 0067. Let's take a look at each of these. 0064, and again you can refer to the cheat sheet, that's the first install time. The same information could also be found in setupapi.dev.log. But if you look over here, you will notice that 6/3/2017, 4:27:34 a.m. UTC was listed as the install time, the first install time for this particular USB device, and that is in fact correct. That is the time I first plugged the device in, 4:27:34. Now, 66 right here, 0066, will show the last connected time. The last connected time is the same, 6/3/2017, 4:27:34 UTC. That would tend to indicate that the first time I used the device was the last time I used the device. So I've plugged the device in once to this VM, and that is in fact correct. So another useful piece of information. Again, you could also find similar information by looking at the last write time of the USB serial number key under enum USB vid PID, or you could look at the mount points 2/GUID last write time, as we mentioned earlier, to find the last connected time. But again, that's 66. And now if we go down to 0067, which is available in Windows 8 and later, we'll actually see the last removal time. You can see about a minute later, 4:28:40 UTC, I removed the drive from the system. And that is absolutely correct. I had it in there for around a minute or so and ejected the drive. So again, these particular keys and values provide additional forensic information about USB devices, and certainly this information could be very valuable during a forensic investigation. And then of course I had mentioned that setupapi.log under XP or setupapi.dev.log under Vista and later will contain a lot of useful information as well, specifically with regards to the information you would see in 0064 about first install. You can see here I've got notepad /Windows /INF /setupapi.dev.log. And if we pull that up, sure enough, here is the device install log for this particular computer. And if you scroll down through here, you would also be able to find the same information that you could find in the 0064 key. So let's go back over to the cheat sheet, and now it's time to move on to the next section, which is basically going to be a combination of miscellaneous information that you may want to grab when you're conducting a forensic investigation. So we'll take a look at that next. Okay, so let's head back over to the Windows 10 VM and take a look at some of these miscellaneous registry keys that may provide useful information during a forensic investigation. You can follow along on the cheat sheet starting here. So I've got the System Hive still open with Registry Explorer. I'm under control set 001. And let's go ahead and drill down underneath that to control and time zone information. Anytime we are conducting a forensic analysis of a system, the time zone information is going to be very, very critical. So you would certainly want to record that before you begin your analysis. That way any time zone conversions that you make or event correlation you perform is accurate. A lot of times when we forensicate a workstation, we'll choose to work in UTC so that we don't have to worry about any said time zone conversions, but perhaps we are writing a report or providing some additional information. It is often necessary to know what time zone the computer is in for performing any of those conversions. And again, you can see here the time zone key name is Eastern Standard Time. So again, very important information here, and we would certainly want to record that. Another thing underneath control would be the computer name. The computer name of the particular computer that we're analyzing. So if we go up here to computer name and drill down to computer name, and then underneath that, computer name, we finally have the name of the computer, which in this case is Catan VM. That's a Star Trek The Next Generation reference if you get that. But this is the name of this particular VM. So again, another important piece of information that we might want to record during a forensic investigation. Now, the next key that we're going to look at is not under control, but it's actually under services. And underneath that, we're going to scroll down to LANman server. And LANman server is actually going to have some information with regards to any shares that are configured on the system. So under LAN server, you'll see shares, and we actually have none on the system, which is correct. I don't have any particular shares other than the default admin shares, $C and so on and so forth. But if I had any shares configured on the system, I would find them there. So again, this is another useful piece of information on a forensic workstation that may be applicable to your investigation, and you may want to record that information. Another one under control, again, if we go back, there is a particular key underneath control that is called file system. And file system, if we look at it, actually has a very long key called NTFS disable last access update. So if you're familiar with Windows timestamps, which we really haven't discussed here, you've got what's called MACB times. That's modified, access, changed, and birthed, MACB. Those refer to timestamps that are collected within the NTFS file system for different objects within the NTFS file system, different files and things of that nature. So we've got for any given file a modified time, an access time, an MFT record change time, and a birth time, which is the file's creation time. By default, NTFS disable last access update, which we will find here in this particular area, is set to 1, which means it is disabled. That means that access timestamps, in other words, the A and the MACB, the access timestamps are off by default, which means that simply accessing a file will not necessarily change the access timestamp associated with that file. That's done likely for performance reasons, and while you could go in and modify this, it is not something that is normally done, and it is turned on, which means it is disabled by default. So you may want to take note of that. It may be different on the system you're analyzing, but it's unlikely. And again, that means that the access timestamps should not necessarily be updated every time a file is accessed. They are updated under various circumstances, and we'll get into that in a future video. But that is an interesting registry key to note. So moving down the cheat sheet here, if we go back to services, there are other pieces of information here that will certainly be valuable to a forensic investigation. So going down to services, we can scroll down all the way near the bottom to TCP/IP, and we can actually get a wealth of information with regards to the network configuration on this particular system. Now, we're also going to talk about that in some future artifacts here on the cheat sheet, but if we just wanted to record, for example, some information about the interfaces configured, we can drill down into TCP/IP parameters, interfaces, and we've got various interfaces here. And as you can see here on this first one, I've got the DHCP IP address, the subnet mask, the DHCP server, the lease time, and various other pieces of information here. And the same information is recorded for these other adapters as well. So certainly very important information that we would definitely want to record during a forensic investigation. What IP address was assigned to this particular system when we're forensicating it. So again, this is under the services TCP/IP parameters interfaces configuration here. So again, very, very important. This displays interfaces and their associated IP address configurations, and you'll certainly want to record the interface goods as well here in your forensic notes. So next we're going to move on to something called network location awareness, which was actually something that was added in Vista and later. So that'll be our next section of the video. Okay, network location awareness, or NLA, was included in Windows Vista and later, and what it does is it aggregates network information for all of the different networks that a particular PC is connected to. It generates a GUID for each network, which is almost like a network profile. Now the Windows firewall will use that information to apply firewall rules to the appropriate profile, but we as forensic investigators can use that information to find evidence of every network that a machine is connected to using these NLA registry keys. So looking at our cheat sheet, it says here to check the last write time of a key to determine the last time a PC connected to a particular network. So again, very important information can be gleaned from this particular key. It's under software, Microsoft Windows NT, not Windows, current version network list. So back on our Windows 10 VM here, I've actually gone ahead and opened the software Hive with Registry Explorer. And I've drilled down, as you can see, to Microsoft Windows NT, current version, network list, signatures, unmanaged. And underneath this, I've actually got 3 different profiles that appear. So I'll click on the first one, and I'll see things like default gateway MAC, which is in fact the MAC address of the gateway used for this particular connection. Now obviously I can glean some information from this. I could take the first half of the MAC address, which is the OUI, and determine the organization to which that particular OUI was assigned. So that might be interesting. I can look at the DNS suffix. In this case, not very interesting. It's just local domain, but it may be a corporate network or something to that effect. First network, which on a wireless connection will actually be the SSID of the network. And then the profile GUID, which we'll want to take note of for each of these. In this case, it ends in BC6. So referring back to the cheat sheet, there's actually a profiles key here, and underneath that, here's BC6. And if I refer to it, there'll actually be a name type value here of 6. 6 is indicative of a wired network. 47 would be indicative of a wireless network, and 17 would be a broadband network, something like a cellular modem connection or WWAN, something like that. So we'll also find here date created and date last connected. Now these are kind of odd looking dates. The reason why is because that's actually a 128-bit Windows system time structure stored in UTC. So I know we were talking about time conversion earlier. There's actually a neat little utility I'd like to mention. It's called Decode. This particular version is 4.02a, and this neat little utility will convert all kinds of time and date values. If we look at the drop down here, it's not just Windows either. It'll do Windows and Linux and Unix timestamps of various kinds, but I'm going to select Windows 128-bit system structure. Now, this particular data actually has dashes in it. It does not want the dashes, I can tell you from experience, and I've gone ahead and copied it and removed the dashes. So I'll copy that, which ends again in B01, which you can see is the date created time here. I'm going to paste it here and click Decode. You'll actually see apparently this date created date is actually Monday, 6 February 2017, 1938. So, very interesting information. I could do the same thing for date last connected to actually determine both the first and last time this particular network was used. And of course I can do that for each of these profiles. So as you can see, the NLA information here would be very valuable in a system. Now it's also important to note, if you look back at the cheat sheet, that there's also HKLM's software Microsoft Windows current version home group, which will also store some network related information in some cases. And back in the Windows XP days, we actually found the same thing under software Microsoft WZC SVC parameters, interfaces, and a GUID. That was the Windows 0 configuration service. And you could use the last write time of the key there to determine the last time the network was connected. So back to our cheat sheet, let's go ahead and move on to the next section, which is link file analysis. Okay, it's time to have the talk about link files. Do not ignore LNK files in your forensic investigation. They contain a wealth of data. Now you may be familiar with the files from manually creating shortcuts to programs or various other things on your system, but you may not realize that Windows automatically creates link files for a number of different actions that you perform on the system. If we go over to the Forensics Wiki website, which is a fantastic digital forensics resource, and look at the LNK file article here, we'll actually see that it says the Windows shortcut file has the extension .lnk, and it's basically a metadata file that's used throughout the Windows platform. Now, the signature of the file is 0x4c, as you can see here, 4c000000 if we're carving for them, which is something we often do. But you may not realize all of the different metadata associated within one of these files. For example, the MAC times of a target that the link file is referring to can be found within that link file, as well as the original path of the file, the size, the serial number of the volume where it was stored, the network volume share information, the attributes, even in some cases the MAC address of the host computer on which the leak file existed, and various other pieces of information. Now this is important because let's say there's a very important file that you believe once existed on a system, but it's been erased, maybe securely erased. What the person may have forgotten to do is delete the link files associated with that file. And we can glean a huge amount of information and prove that the file once existed on the system by analyzing those link files. So if we go back over to our Windows 10 VM, we can see here that I'm in my user profile under App Data, Roaming, Microsoft Windows, Recent. So on the desktop here, I'm actually going to right-click and create a new text document. I'll just call it secret.txt. And we'll just go ahead and say this is a secret file. I'll go ahead and close and save it. And now you'll notice secret.txt on the desktop. You'll notice secret.txt here under recent items. But this is actually secret.txt.lnk. This is the link file associated with the creation of secret.txt. So let's copy this file and let's take it over to the SIFT workstation and paste it. And let's use EXIF tool, which is commonly used to analyze metadata from pictures and various other files. And if we do that, we'll actually see that there's a good bit of information that we can glean from this particular link file. We can see the original file size of the target along with the MAC times. We can see information about the attributes associated with the file. We can see the original path for the file, the fact that it was on a fixed disk, the label of the volume on which it was accessed, which is OS, the working directory, even the name of the machine on which the file existed. So a huge amount of information. Now, there are also utilities from TZWorks like lp.exe, which is referenced in the cheat sheet, and various other utilities that can analyze link files as well. But the important thing to know is do not ignore them. If you're performing triage on a system and you're grabbing a subset of the information you need to perform forensic analysis on a system, and you grab the registry hives, let's say, and NTUSER.DAT and UsrClass.dat and various other things in the system, do not ignore LNK files. Grab them. If you're building a custom content image with FTK Imager, for example, make sure you include LNK files as part of that data that you grab, because there are plenty of things here that will help you within the investigation. Now, looking at the cheat sheet, you'll also notice there are a couple of subdirectories that can exist called automatic destinations and custom destinations. These are associated with something called jump lists, which were things that were introduced with Windows 7. It's actually a feature of Windows 7. And what it does is it actually provides on the taskbar a way to quickly access files that you've recently interacted with. For example, if you have Word on the taskbar and you hovered over it, you might see a list of recent files that you've interacted with Word. So automatic destinations and custom destinations just contain additional link files that can be analyzed. I'm not going to get into the specifics here, but I would encourage you to read this article about jump lists on the Forensics Wiki, as well as the original article I showed you just about Windows shortcut files in general. And again, there are a number of different utilities that can parse these files, but the important thing to take away from this is learn more about link files and do not ignore them in your investigations. So this video is getting fairly long at this point. As you can see, we've only scratched the surface of the vast majority of things that are available here on a Windows system to analyze and forensicate. And we'll actually move into our final section next, which is going to talk about Prefetch and Superfetch. Okay, we are now in the final section of this video, and if you've made it this far, thank you for watching. We're now going to discuss Prefetcher and Superfetch, both of which are part of the Windows Memory Manager. Now, Prefetcher was the less capable version included in Windows XP, but it was actually extended by something called Superfetch in Windows Vista. We also had in Windows Vista Ready Boost and Ready Boot, if you remember those. All three of these have in common the fact that they attempt to improve the user experience by caching data that is frequently used and accessed on the system to make it faster for the user. So, like all of the other forensic artifacts that we've looked at, these things were put here by Microsoft to, again, perform some other function other than forensics, but as forensic investigators, we can leverage this to show evidence of application execution. Now, in the beginning of the video, you'll recall that we talked about UserAssist, which showed evidence of GUI-based application execution, and that was a registry key tied to a specific user, because it was in the current user hive or NTUSER.DAT file. So with this prefetcher, we can actually look at evidence of application execution globally for all users on the system, and it would include not only GUI-based applications, but things run from the command line as well. Now, because this is not a registry key, it's not tied to a specific user per se, but we can still gain a wealth of information by analyzing these files. If you look, I'm in Windows Prefetch on this particular Windows 10 VM, and you'll see various things, executables in all caps, like calc.exe, followed by a dash and then what looks like 8 random characters. Those random looking characters are actually a hash of the file's path on the system. So for example, with cmd.exe, there's only one prefetch file associated with it, but if there were another cmd.exe on the system located in a different location, we would actually have a second prefetch file for it with a different hash indicating that it's a different path on the system, which might be of interest in and of itself, the fact that we would have more than one cmd.exe present. So there are a number of tools that can analyze these particular files, but the one I'm going to show you is WinPrefetchView, which I've already loaded here. This is a tool from Nearsoft, N-I-R-S-O-F-T. They make a number of different free forensic utilities that provide all kinds of useful information, so you might want to check those out. What I'm going to do is run a particular piece of software, really a program called WinVer, which just displays the About Windows dialog box. Now, I'm just going to close this. I've not run this previously. So the reason why I did that was to show you that there is no WinVer present. There's no prefetch file. But if I refresh the screen here, I can actually go down and I see WinVer now. And if I double click on it, I'll actually see some interesting information, including the process executable name, the path, the run counter, and the last run time, showing that I've run it once and it was last run on this particular date. If I run it again, and then once again refresh the data, double click on it, you will notice the run counter is now 2, and I have 2 timestamps for last run time. So very interesting information can be gleaned from this. And again, this is not just for GUI-based applications, as was UserAssist. And by the way, there are certainly other things that we can look at to determine evidence of application execution, things like recent file cache.bcf and AM cache. I'm not going to cover those in this video, but perhaps in a future video we'll discuss this. So in this video, this is the second thing that we've looked at. In addition to UserAssist, we've now got Prefetch that can show us evidence of application execution on a system. Now, the final thing I'll show you is in the registry, there is actually a key, which we'll go ahead and load up regedit and look at the live registry on the system. There's a key under local machine, system, current control set, control, session manager, memory management, prefetch parameters. You can see the full path here at the bottom. The enable prefetcher key has a value of 3, which if you look at the cheat sheet, you'll see that's the default, which does mean that application and boot prefetching are enabled. Now, if you do not have prefetch files on a particular system, it could be because this is disabled. It is important to note that on Windows Server operating systems, prefetch is not turned on by default. So that might be something interesting to know. But if you're analyzing a desktop operating system, Prefetch, again, will provide you with a wealth of information, and certainly you would want to grab PF files when you create custom content images. I mentioned before the importance of link files. Well, certainly don't forget PF files either, because they'll show us all kinds of important information with regards to applications that have been launched on the system. So that concludes this video. I'm sorry if it went a little long, but there were a lot of things to cover, as you can see, and we've only scratched the surface of the wealth of forensic artifacts that are available in the Windows operating system. I'll probably do some future videos to cover more specific things, but at this point, I think if you've covered the contents of this video, you'll have at least a solid foundation for the basic and very common Windows forensic artifacts that we often look at. So again, I'd like to invite you to subscribe to the channel, like the video, and all the other YouTube stuff that I'm supposed to say at the end of every video. And I would like to thank you for watching.